Hey everyone, and welcome back for another deep dive.
Yeah.
Today we're going to be looking at something pretty cutting edge.
Oh, yeah?
It's called compressed chain of thought efficient reasoning through dense representations.
Catchy title.
Yeah, a little bit of a mouthful,
It is.
but I think it's really interesting research.
I agree.
It has to do with language models.
The brains behind all the fun stuff.
Right, and kind of how they think and...
How we can make them think better.
Yes, exactly. Like, how do we make them reason more effectively?
More efficiently.
And,
Especially when it comes to complex tasks.
yeah, like a lot of times we've seen, they've used this thing called chain of thought prompting.
Right. Like thinking step by step.
Yeah, like thinking out loud almost,
But,
which can be really useful, to make sure they're going through the steps and getting the right answer.
right.
But it has a problem.
It's slow.
Yes, exactly. It takes a long time.
Way too long.
Yeah, and the paper actually points out an example with GPT-4,
Yeah.
where with this kind of like step-by-step prompting, it took something like 21 seconds to answer a question.
Really?
But when they asked it the same question,
Without all that extra stuff?
without the step-by-step part, it only took 2.8 seconds,
Wow.
which is like almost 10 times faster.
Huge difference.
So,
Nobody wants to wait that long for an answer.
right, exactly. I mean, can you imagine?
Yeah, it would be so frustrating.
If you were like, hey, what's the capital of France? And you're just sitting there waiting.
Right. Come on, spit it out. It's like, finally,
Yeah.
Paris.
Yeah.
20 seconds later.
So how did they approach this problem?
Well, basically, they asked a really interesting question.
Okay.
Can we make these models more efficient without sacrificing their ability to reason to
Okay.
get the right answer?
Okay, so we want them to be fast, but we don't want them to be
Dumb.
Yes, right.
Exactly.
We want them to still be able to get to the right conclusion.
Right, and that's where compressed chain of thought comes in.
Okay, so CQOT, for short.
CQOT. Okay, so how does this CQOT thing work?
Well, it's kind of like...
Is it like summarizing the thought process?
It is like summarizing, yeah. You're
Yeah.
taking that long, rambling thought process, and you're
Mhm.
kind of condensing it.
Okay.
It's like taking a big, long book, and you're turning it into bullet points.
I like that analogy.
Or you're compressing a file.
Right.
You still have all the information,
Yeah.
but it's just packed in a much smaller space.
Okay. And so what they're doing is instead of the model like spitting out this whole paragraph
Right.
of thought,
It's like
it's condensed.
a little snippet.
Okay, but that doesn't mean it's thinking any less.
Right. That's the key.
Right, okay.
It's still doing all the thinking.
Oh, yeah.
It's just not wasting time
Right.
writing it all out.
So it's working smarter, not harder.
Exactly.
Right.
Much more efficient.
Okay, I'm already seeing like the potential here.
Right.
But let's, before we get ahead of ourselves.
Let's break it down. Let's break down how this CCOT magic actually works.
All right, so imagine instead of generating a whole chain of reasoning,
Okay.
it's creating a dense representation of that chain.
Okay.
Like if you were reading a paragraph
Right.
and you highlighted just the key sentences.
Okay.
That's kind of what CDOT is doing.
So it's like distilling the essence of the thought
You got it.
into like a concentrated form.
Yep. And what's even cooler is you can adjust the compression ratio.
So we can...
Fine-tune that balance between speed and accuracy.
Okay. So we're talking about like a knob
Exactly.
where we can say, okay,
Like how much do you want to squeeze this?
yeah, how much do you want to compress it?
Exactly.
Okay. So you mentioned compression ratio.
Yes.
And I have to admit, that's piquing my curiosity.
Sure.
What do those numbers actually mean?
Well, think of it like summarizing information.
Okay.
A higher compression ratio means you're squeezing more information down.
Okay.
It's like going from a detailed report to just a few bullet points.
So a higher ratio means faster processing.
Right.
Because it's using fewer of those like tokens or whatever
Exactly.
to represent the process.
Fewer tokens.
But does that mean it's less accurate?
Well, that's the trade-off.
Okay.
It's like choosing the right file format for an image.
Okay.
You want it to be small enough to share easily,
Yeah.
but not so compressed that it loses quality.
Right. That makes sense.
So finding that sweet spot
Yeah.
is really important.
So how do they find that sweet spot? What kind of experiments did they run to test this?
Well, they tested CTOT on a data set called GSM-8K,
Okay.
which is a collection of math word problems.
Okay. So this...
These aren't like your basic arithmetic problems.
Right. This is real reasoning.
These require step-by-step reasoning.
Okay. So they really put it through its paces.
Yeah, they wanted to see,
Yeah.
can it handle this kind of complex problem solving?
And how'd it do?
It did great, actually.
Really?
Yeah, CTOT significantly outperformed other approaches.
So it's not just fact.
It's accurate, too.
It's accurate. Okay, this is really exciting stuff.
Right.
Like, imagine if your, AI assistant
Yeah.
could give you a really complex answer,
Right.
but almost instantly.
Think about the implications for
Yeah.
like education.
Oh, yeah.
Students could get help
Yeah.
with difficult concepts.
Or for research.
Exactly. Scientists could analyze data so much faster.
Yeah. And even just like everyday problems.
Oh, yeah, totally.
If you need help planning a trip
Or troubleshooting
Yeah,
something.
yeah.
It's like having a super smart friend in your pocket.
Yeah. Okay, so let's get into the nitty-gritty.
All right, let's do it.
How does this actually work?
So we've established that CQOT is like creating a zip file
Right.
of the reasoning process.
Yeah.
But how do they actually teach the model to do that?
Right.
Well, there are two main parts.
Okay.
First, during training,
Okay.
they give the model a query, a full reasoning chain, and the correct answer.
Okay, so it's like learning by example.
It is learning by example.
Okay.
But how does that lead to compression?
Right.
That's where the second part comes in.
Okay.
Remember those hidden states we talked about?
Yeah.
They're like the internal notes the model makes
Okay.
as it's processing information.
Right, so those were the things being compressed.
Exactly.
Okay.
So they're training the model
Okay.
to generate these compressed representations of the reasoning chain.
Okay, so it's creating like a summary
It is like a summary.
of its notes.
Exactly.
But how does it choose
That's a good question.
which notes to include in the summary?
So they actually experimented with different methods.
Okay.
One approach was to use a separate scorer module,
Okay.
kind of like a filter that identifies the most important hidden states.
Oh, okay. So it's like a
It's like a little judge.
judge that says.
So this one's important.
Yeah.
This one's not.
Okay.
Another approach was to just select states at even intervals.
Okay, so like every other note or
Yeah, like every fifth note.
Okay, interesting.
Like trying different ways
Yeah.
to figure out what works best.
Okay, so once it creates this compressed summary of its thoughts,
Right.
how does it actually turn that into an answer?
Well, that's where another part of the model comes in,
Okay.
which they call decode.
Decode, okay.
So decode takes that compressed representation
Okay.
and translates it into an actual answer.
Oh, okay, so it's like the interpreter.
It's like the interpreter
Okay.
that takes those compressed thoughts
Yeah.
and turns them into something we can understand.
Okay, and here's where it gets really clever.
Oh, yeah.
They actually feed that compressed thought
Okay.
back into itself
Interesting.
during the training process.
So it's kind of like
so it can kind of check its work and be like,
it's refining its own notes.
yeah,
Making sure they're clear and concise.
that's really cool.
Yeah, so that when it comes time to actually answer a question,
Yeah.
it's got those notes ready to go.
Okay, I think I'm starting to get it. But I'm still a little fuzzy on the compression ratios.
Okay.
Like, how does that actually work in practice?
Sure, so imagine you have a math problem
Okay.
with a reasoning chain that takes 100 words to explain
Oh,
with a 10x compression.
okay.
The model would aim to represent that same thought process using just 10 words.
Oh, wow. Okay.
So it's picking out the most essential points.
Okay, so higher compression means it's really trying to...
It's really squeezing it down
Yeah.
to the bare minimum.
Okay, but as you said earlier, there's a trade-off.
There is.
What happens if we push that compression too far?
Well, it's like trying to cram all your belongings
Right.
into a tiny suitcase.
Yeah.
You might have to leave some important things behind.
Right.
Similarly, if you compress the model's thought process too much,
Okay.
you risk losing some crucial details.
Right, which could make the answer wrong.
Exactly. It could lead to less accurate answers.
So it's really about finding that balance.
It's all about balance.
Okay, what did they learn about how to find that balance?
Well, they found that accuracy tends to plateau
Okay,
after a certain point.
okay.
So even though the model is processing information faster
Yeah,
with higher compression,
yeah,
those condensed representations
right.
might be missing some key pieces of information.
Okay, so there's no free lunch.
There's no free lunch.
Okay, so it's about picking the right...
Tool for the job.
Yeah, like if you need a really fast answer,
Right.
you might have to sacrifice some accuracy.
Exactly.
But if you need something more thoughtful,
Right.
CQOT can do that pretty quickly.
It can. And that's what's exciting about this.
Okay.
It gives us more flexibility
Right.
and control.
So it's not just one size fits all.
Exactly. We can tailor it
Okay.
to the specific task.
Okay, and now, remember, we talked about how the model picks which hidden states to use.
Right.
They actually found that the specific layer
Oh, yeah.
that they choose
Uh-huh.
can really impact performance too.
It can,
Why is that?
well, it's kind of like choosing the right zoom level on a map.
Okay.
If you zoom in too close,
Yeah.
You might get bogged down in the details
Right.
and lose sight of the bigger picture.
Right.
But if you zoom out too far,
Yeah.
you might miss important landmarks.
Right.
So choosing the right layer
Okay.
helps the model strike that balance
Okay.
between specific details and broader context.
So it's finding that sweet spot again,
It's all about finding that sweet spot.
where the information is both comprehensive and
That's-
concise.
Exactly.
Okay, so choosing the right layer is super important.
It's crucial
Okay.
for making sure that compressed thought process
Yeah.
retains all the necessary information.
Okay, so we've talked a lot about the practical applications of this,
Right.
but the researchers also kind of explored some
Yeah.
of the theoretical implications.
Some deeper stuff.
Yeah. Lay it on me.
So think about how traditional computers work.
Okay.
They often focus on doing lots of things at once, what we call parallel processing.
Right.
But a lot of real-world problems
Yeah.
require a more sequential approach,
Okay.
where one step leads to the next.
Right, like solving an equation.
Exactly like solving an equation.
You can't just do it all at once.
You got to follow the order of operations,
Yeah.
and that's where CCUT really shines,
Okay.
because it's generating those compressed tokens
Right.
one after another.
Okay.
It allows the model to build on previous steps
Okay.
to carry information forward.
So it's more like how humans think.
It's more like how we think.
Wow. Okay, so are we saying that CQT is not just making models faster,
Potentially.
but potentially changing how they solve problems?
It could be a whole new way of thinking
Okay.
about AI.
This is blowing my mind a little bit.
It's pretty wild.
Yeah, okay, so, but before we get too carried away,
Right.
I know there are some limitations here.
Of course.
What are some of the things
Yeah.
that we still need to figure out?
Well, one of the big ones is that right now, CCOT still needs to see those complete reasoning chains during training.
Oh, so it still needs that cheat sheet.
Exactly. It's like it needs to study the textbook before it can start taking its own notes.
But we want it to be able to figure out those shortcuts on its own eventually, right?
Right. That's the goal.
So how do we get there?
That's a big question for future research.
Okay.
We need to find ways to train these models,
Right.
to compress those chains without needing to see all the steps spelled out.
So like teaching someone to summarize a book without giving them the Cliff's Notes.
Exactly.
That sounds like a pretty tough challenge.
It is, but that's what makes it so exciting.
Okay, what other challenges are researchers working on?
Well, remember we talked about those different methods for selecting which hidden states to compress?
Yeah, like that scorer module or the even intervals.
Right. There's a lot of room for improvement there.
Okay.
They're trying to find the most efficient way
Yeah.
to pinpoint those essential reasoning steps.
So it's like finding the best packing strategy for your suitcase.
Exactly. You want
Right.
everything to fit perfectly.
Without getting wrinkled.
Exactly.
Okay, what about speed? Even with COT, there's still some overhead compared to just spitting out an answer, right?
That's true. Those compressed representations still take some time to process.
So it's a balancing act again.
Always a balancing act.
So if you need a super fast answer,
Right.
you might have to sacrifice some reasoning.
But if you need a more thoughtful response,
Right.
CQT can give you that with impressive speed.
Okay, so it's about picking the right tool for the job.
Exactly. And that's what I love about this research.
Yeah.
It gives us more options, more control over how we interact with AI.
So it's not just about making AI faster,
It's about making it more adaptable.
more intelligent.
Exactly.
This has been an amazing deep dive into compressed chain of thought.
I agree.
We've learned how it could revolutionize AI,
How it works.
the challenges ahead.
The possibilities are endless.
And you know, one thing that really struck me
What's that?
is how this research kind of blurs the lines
yeah.
between artificial and biological intelligence.
I know what you mean.
If these language models can compress their thoughts,
Right.
does that mean our brains might be doing something similar?
Whoa, that's a deep thought.
Yeah, like maybe our brains are running their own compression algorithms.
To handle all the information we process.
Right. It's kind of mind-blowing.
It is. It really makes you think.
It does. So if you're as fascinated by this as we are,
Definitely check out the paper.
yeah, it's called Compressed Chain of Thought Efficient Reasoning Through Dense Representations.
It's a good read.
It is, and who knows what other incredible breakthroughs are just around the corner.
The future of AI is looking bright.
That's for sure. So until next time, keep exploring, keep questioning, and keep diving deep.
See you then.